I'll move around. All right, section 1.1, just so that you guys know what it's about parents and transformation. Now, parents is not your parents, Sammy. Okay? Mom and dad are not in this thing. But parent functions are kind of what they are. They're the ones that you start off of, and then after that, you transform it. Okay, we might translate it. We might reflect it. We might stretch it or shrink it, all that kind of stuff. Now, when you get to college algebra, which I started teaching last night, but when you get to college algebra, there are more parents than what you guys are going to be responsible for right now. You're only going to have 4 parents that you're going to be responsible for. Okay? The first parent function is going to be called linear. Does anybody know what kind of graph it's going to be? A line, right? Since it says the word line in it or linear in it. And that parent function looks like this. F of x equals x. Okay? Now, what I need to explain to you guys a little bit about f of x. F of x is a function notation. It's always going to be f of x like that. It's not going to be y equals, although that's how you would also interpret that. F of x and y equals are the same thing, just so that you know. So when you get to your graphing calculators, when we have y equals button, when we graph them with it, that's the same as f of x. Okay? So f of x and y equals are identical, just so that we know that. Is everybody okay with that? Okay, that's the first parent that we're going to work with. The second parent that we're going to work with is absolute value. Absolute value has the absolute value symbols in it. How do you know the difference between linear and absolute value? Maybe you have an idea. What's the difference between linear and absolute value? Nobody has any. The 2 lines in there, yeah, that's pretty much it. Okay, absolute value for as far as the graph looks, the lines. I think you guys pretty much know what a line looks like. Does anybody remember what an absolute value graph looks like? No? Okay. A line graph will be a line. Okay, that's what a line graph would look like. An absolute value graph looks like a V. Why does it look like a V like that? Okay, because an absolute value graph on that particular thing, and I put it in the wrong spot, but for an absolute value thing, it can't be, when you put in the numbers, when you take out that absolute value, remember that's the distance from 0. Can distances ever be negative? No. So therefore, that's why it bounces back up. It doesn't continue like the line does. Okay, so an absolute value shape is going to look like a V. The next parent function that we're going to have is going to be the quadratic. Okay. Now, quadratic is kind of different because of the fact that when you hear the word quad, especially if you do anything in motocross or anything like that, you hear quad, that usually means 4. That has nothing to do with it when it comes to math. Okay? Quadratic means the highest exponent is going to be a 2. That's what a quadratic is going to mean. So the parent function is going to look like this. F of x equals x squared. Does anybody remember what the graph looks like? You may have seen it in Algebra 1. I'm not sure, though. No? The graph of something like this looks like this type of shape. Anybody know what that's called? What, Sammy?
I didn't say anything.
You didn't say anything? Somebody did. Parabola. Right. That's a parabola. Has anybody ever seen a parabola before? In real life? If you say no, then you're wrong, because all of you have. All of you have ate at McDonald's at least once in your life, I'm assuming, right? Does McDonald's have in their symbol 2 parabolas? Yes, they do. Anybody been to St. Louis? It's a big one there.
Oh, the gateway arch.
Yep, the arch. Okay, those are all parabolas. So quadratic one looks like a parabola. The last one that's also in there, and I almost forgot about it, is what they call constant. That's the third or the fourth one that they actually list in here. And constant is nothing more than f of x equals, and it says 1, but I'm going to just say a number. Okay, when it says f of x equals a number or f of x equals 1 like that, that is a horizontal line. That's what that is. So these graphs for this one, that would just be a horizontal line. Can't do that because it's there. Like that, like the bottom one. Okay? So those are the 4 parents that they're going to work with. So when we talk about identifying it, I want you to look for what kind of shape is it. Okay? Does it curve? Does it have a V? Does it have a diagonal line? Does it have a straight line, a horizontal line? What does it have? That's what you're going to look for. The other thing that you can look for is obviously looking at the equation itself. If x is squared, it's going to be a quadratic. If you have the bars, the lines, like Tamara said, say it right? Tamara. Oh. Okay? Then it'll be an absolute value one. If it just has x, then it's going to be a linear one. If it has just a number, it's going to be a constant. So they're going to ask you to identify what kind it is. That's what they're going to do. Whether it's just the equation or whether they give you the picture. That's what they're going to ask you to do for the first one. So if I gave you an example of something, by the way, when you make your graphs, I usually use what I call a homemade graph. I will make one like that. That's horrible on the one side. It's not straight. But I usually make a homemade graph like this on my paper. And then what I will always do is I will always label my axes with x and y. Do you have an idea why that might be important to label the axis? Because if I give you this line right here like this, and say identify what the equation is, and if I don't have it labeled, what if this isn't there? Do you know which one was supposed to be the axis and which one's the line that we're supposed to be working on? No. So that's why it's important. Always label your axis, and whenever I do that is I label the x on the right side, the y on the top. Those are the positive sides of it. That's how I label them. So what kind of family is this in? Is this parent a constant, linear, quadratic, or absolute value? Constant, because it's a horizontal line, right? What about the red one? Absolute value. Why was it absolute value? It looks like a V. What about the green one? Quadratic. Where most people get confused with this is the difference between absolute value and quadratic when they look at the shapes. Because U's and V's can look a lot alike, especially if you're not sharp with your lines. What I mean by that is, my V looks, you can tell that's a V. But what happens if you make a V where you kind of curve that bottom part? Could it look like a quadratic then? You got to be careful with that, okay? And then the last one, if I gave you one like that, I'll go orange. That one's a what? Linear. Because it's a line, but it is diagonal. That's why it's not constant. Notice I did not put a vertical line up there. Does anybody know why? Anybody have any idea? Do you know what a vertical line is? Straight up and down, right? Vertical lines are not functions. They're not functions. That's why the vertical line is not on there, because why it's not a parent function, because vertical lines do not pass the vertical line test, so therefore it's not a function. So that's why they're not included. Okay? Not that I wanted to leave it out, but like I would never want to leave out you, Mr. Benjamin, but it might happen. Okay? So, as far as identifying it, looking at the picture, are you guys okay? Those are the only 4 you're going to see. Are there more than that? Yes. There are way more than that. And we'll talk maybe about them later, but for now, this is the only 4 that we're going to work with. Okay? Is everybody okay with identifying it? Good. The next type of thing that we're going to work with is the type of transformations. Now on the posters over there on the wall, those are for geometry, but realistically, those actually come into play also. The second one over, the one that says translation, does anybody remember from geometry what a translation is? Nobody remembers? What a translation is it's a shift. Okay? So for instance, right now this nice round table looks great here, but what if I move it right here? Did I change the size? Did I change the shape? I just changed the location it's in. That's what a translation does. It's adding or subtracting. Okay? That's what's going to happen. So when you do a translation, it's nothing more than a shift. Okay? A translation is going to equal a shift. That's what it's going to be. Okay? Adding or subtracting. That's what's going to happen to my parent. I am going to add or I'm going to subtract from the parent. Now, this is the important part, and this is where it's going to come into play, which way it shifts it. If you add or subtract outside a grouping symbol, and I'm going to abbreviate grouping symbol as GS, is everybody okay with that? That is going to shift it up if you're adding, down if you're subtracting. So if I took one of the parents and I put +3, that would shift it up 3 units. So basically what happened is I would grab it, 1, 2, 3, and then drop it, and there it is. Or if it said -7, I'd grab it, 1, 2, 3, 4, 5, 6, 7, and then drop it. Did I change the shape? Did I change the size? No, I just changed the location. If you're inside the grouping symbol, and what I mean by inside the grouping symbol, you will actually see a physical grouping symbol. What kinds of things are grouping symbols? Parentheses is the big one that we use. One of the parent functions has a built-in grouping symbol. Which one is that? The absolute value one. The absolute value one is a grouping symbol itself. So those bars, if it's inside the bars, okay, that's what that means, or if it's outside the bars. Or if it has parentheses, then they have that's the other grouping symbol we're going to use for these parents. There isn't any other kind of parents that we're going to work with this so far. If we're going to shift it to the right, that's if you're subtracting inside the grouping symbols. And it goes left if you're adding. Now, I want you to think about that for a second. Most of the time when we talk about moving on a number line, when we go right and left, on a number line to the right, that should get bigger, right? You remember that? When you're adding on a number line, you go to the right, that's bigger, so it seems like we should be adding, but realistically, if it's in the grouping symbol, it's subtracting. So if it's got parentheses and it says like x minus 3, that really means we're going to go right 3. Whenever you take something out of the grouping symbol, when you pull it out of there physically, what happens is the sign changes. So if you had something like x minus 3 in parentheses, when you pull it out, you're really going to go to the right 3, or plus 3. If you had x minus or plus 7 on the inside, when you pull it out, you're going to go left 7, or negative 7. So anytime it comes out of the parentheses, it goes the opposite direction. And it's outside the parentheses, it actually goes up or down depending on if it's positive or negative. Does that make sense so far? Now here's how they're going to look. They're going to ask you something like this, where it says graph blah and its parent. Describe the transformation. So if it says g of x equals x minus 4, the first thing that helps me is identifying what the parent is. What is the parent? It's linear. How did you know it was linear? Because the x, right. When you're identifying what parent it is, you look for some of the key features. Is the x squared? No, so it's not quadratic. Is there absolute value bars? No, so it's not absolute value. Is it just a number? No, so it's not constant. It's x, so therefore it's linear. So when they ask you to identify the parent, it's linear. That's all you would write. You would write linear. If I could spell. You'll figure that out. I'm not a good speller. Now, as far as graphing it goes, first thing I'm going to do is I'm going to graph the parent. So I'm going to put the parent in black just so that we know what the parent looks like. Does anybody know what the graph y equals x looks like? I kind of put it up there, but I kind of didn't really talk about it. But does anybody know what it looks like? If I gave you the equation of y equals x, how would you graph that?
Is it a horizontal line on the x-axis?
Not quite. Not a horizontal line, because we're diagonal with this one. Diagonal through the middle. Right. It goes like here. That's the parent. Now, how would I get that without using that or knowing that parent? Keep in mind the number on the outside. Remember when you dealt with lines back in Algebra 1? The number, the y-intercept was on the outside and the slope was in the front of it. So the b didn't have anything, so we'd start at 0. Up 1 over 1, up 1 over 1. We'll talk about lines later, but for as far as the parent goes, that is the parent. So that's the one I start with. That's my table. Now, according to what they have over there when it says x minus 4, is that minus 4 inside a grouping symbol or outside of a grouping symbol? Let me ask you this question. Is there a grouping symbol at all in that problem? No. If there's not a grouping symbol, then it's automatically outside. Okay? So when it was outside the grouping symbol, which way did it shift it? Did it shift it up or down? Or right or left? Down. How far? 4. Because it says the number 4. Right? So I'm going to take this point, which you guys said, Tamara, right? I said it eventually. Tamara said it goes right through the middle. Well, that is a known point. So therefore, if it said down 4, I'm just going to drop that point and grab everything with it. Imagine like on a computer, if you were to take the hand tool and grab it. You remember ever doing that with stuff and then sliding it down? Okay. Later on, when you guys, juniors, when you take the state assessment test, it's on a computer. That's something that you click and grab and drag. Seniors, do you remember doing that last year on that state assessment test? Where you're going to drag it down 4 units. 1, 2, 3, 4. Now I'm going to make the same line, or try to, as long as I can draw straight. But I just shifted it down 4. Now, when they want you to describe the transformation that took place, what did you do? What did you do for the what did you do for the black line to make the orange line? Shifted it where? Down how many? Good job. Shifted down 4. Realistically, if you just told me down 4, I'm okay with that. Now, some authors and some people in your life, eventually, not necessarily me, but in the college algebra stuff, I had somebody that I had in grad school that wanted me to tell you that is a vertical translation 4 units down. That's a technical term for it. But realistically, what happened was you moved it down 4. If you just write down 4, great job. Awesome. Okay, I don't need a lot of words. Obviously, I'm a math teacher, not an English teacher. So, describing what happened, we went down 4. Done. That's it. That's what they would want you to do for that first one. Let me give you another one. Okay. First thing I want you to do, what's the parent? How'd you know? Because of the lines, the bars, right? Okay, good. Is that a grouping symbol? Is the absolute value bars itself a grouping symbol? Yes. So, am I adding or subtracting inside the grouping symbol or outside the grouping symbol? Inside. So now I'm going a different direction. So first of all, the parent was absolute value, which you guys hopefully remember. What kind of shape is an absolute value? A V. Where do you think the parent should go through? I didn't do a very good job when I drew the first one. Where should it go through? The center, the origin, right? So it should look like this. Somewhat like that. I'm pretty bad at drawing a V, I guess. But that's where my parent should go, approximately. Now again, if you had graph paper, that would probably look a little bit better. But as soon as I put graph paper on here, the screen goes black. So that's why I don't do it. Now, with the plus 1, is plus 1 inside or outside the grouping symbol? Inside. So therefore, when it comes to inside, now we have to shift it not up and down this time, but to the right or to the left. When you're adding, which way do you go? Left. How far? Right. So what I do usually, or typically, and I even tell my college students this because they do the same things you guys are doing, I will tell them to write the transformation or what's happening first and then go back and draw the picture. Now, when you get your graphing calculators, can you honestly just put that in your graphing calculator and see what it looks like anyway? Yeah, you will be able to. If you've never used a graphing calculator before, don't worry. I'll show you, and we could have typed this in the calculator. The graph for me, I know that you might, not know how to do it right away, but once you get the graphing calculator, it will help. So all I'm going to do is take that V, and I'm going to move it one space to the left. So where do you think I start?
At that space.
What space?
Like the one to the left at the X axis.
Okay, right here at the origin. That's probably the easiest place to start if and whenever you can. So what I would do is grab that, slide it over. So I should have something that looks like this. So not only did I graph the parent, but I also have the new transformed one. Is everybody okay with how I shift up and down, left and right? Quick question for you. Can you do both at the same time? Could I physically move something right or left and then up and down? Absolutely. Okay, so if you have something that's adding on the inside and something that's subtracting on the outside, you can move it up and down and left and right. Now, it will never have something like this, or it will never have move it to the right and then move it to the left. It will never have two inside the grouping symbol or two outside the grouping symbol. It will always have, it could have one of each though, but it will never have two on the inside or two on the outside. Does that make sense? How are you guys with transformations? Or translations? Okay, that's just a shift up or down, left or right. Okay? The next type of transformation is the reflection, which I'm assuming most of you used this morning. Okay? I'm assuming. Unless, you're like me and you just get up and look this good anyway. Okay? But with reflection, what type of device am I referring to with you guys using this morning? Mirror. That's what a reflection is. It's a mirror image. Okay? What else is a reflection called? A flip. Okay? It flips it over. There's two types of reflection that happen. One that reflects it over the x-axis, which means instead of opening up like this, like hopefully we'll see a lot of in Fargo tomorrow for a football team, right? Or if it reflects it, it could go down. So this is the parent right now with the parabola, and then now it will go down this way. It reflects over the x-axis. What's the other way it could reflect? Over the y-axis, which is this way. Which the v's, the absolute values in the quadratics, when you flip them over the y-axis, do they look any different? No. Unless they've been shifted. Then they might look different. But reflection is the two different types. If a negative is outside the grouping symbol, it's reflection over x-axis. So what that means is, let's take the parabola for a second as you write that down. Right now the parabola opens up. If you reflect it over the x-axis, now it opens down. Okay? Tamara said, oh, the arch in St. Louis. That's an example of something that would have reflected down because it opens down. Okay? Most parabolas start by opening up, like hopefully we see the side judge do a lot of tomorrow for football. Okay? But it could open down, like McDonald's symbols, like the arch symbol in St. Louis. Those are ones that have been reflected. So if the negative is outside the grouping symbol, that reflects over the x-axis. What do you think the y-axis does? If a negative is where, do you think? Yeah. Is inside the grouping symbol. Then it's a reflection over the y-axis. On a parabola and on the absolute value, unless it's been shifted, those are not going to look any different. So if I'm like this, and here I am facing you, and all of a sudden I'm supposed to reflect over the y-axis, and here I am, did my arms really move any position? No, didn't do anything. Unless I shifted over from the axis, then you could actually see it. The McDonald's symbol would have been shifted over and then flipped. Then we could have had it. Lines, you're going to see it more than the other ones. But a lot of times when it comes to reflection, we're dealing with the x-axis. Instead of the V opening up, it opens down. Okay, so here's how it looks. If you have f of x equals negative x squared. We'll use the quadratic one since we haven't done that. Oops, I forgot. What kind of parent is this? Quadratic, because I just said it. Has it been shifted up or down, left or right any? Is there any shifting going on? Is there any adding or subtracting anywhere in that problem? No. Could there have been? Yeah. But there's not. There's a negative. Is that negative inside a grouping symbol or outside the grouping symbol? Outside. How'd you know it was outside? There isn't any. Right. There's no parentheses, there's no bars. So that means outside. Good. So if it's outside, which way does it reflect? X-axis or y-axis? X. So reflection over x-axis. Now it's time to draw them. So I'm going to draw my little set of axes there, label my x and my y-axis. Does anybody remember what the first parabola looks like? I've put a couple up there already, but basically it looks like that kind of you. That was actually really good. Gee, I should take a picture of that, save it, sell it. So if I reflect it over the x-axis, which way is it going to go now? So it just goes like this, down instead. So my reflection is going to come in here and do like so. That's what a reflection looks like. It's a mirror, a flip. You flipped it over. Yay, team. Okay. What do you think of reflection? Is reflection okay? If it was inside the grouping symbol, guess what? You would have the parentheses, or you would have the absolute value bars, and the negative would be inside of it. That's what it would look like if it was inside. Okay? The next type of transformation that we have, besides translation and reflection, now we get away from rotation. We don't have rotation. That's geometry stuff up there. But there is translation and there is reflection. Okay? But for the next part, we're going to have what we call stretching or shrinking. That's the next type of transformation that's out there. A stretch or a shrink. In your younger days, have any of you ever had Laffy Taffy? And when you put it in your mouth and you pull on it, what happens to it? It gets stretched out, right? That's what a stretch is going to do. What actually physically happens to the Laffy Taffy is it gets skinnier, right? It gets stretched out so far that it's real skinny that almost it breaks apart eventually. That's what a stretch is going to do. Okay? When you stretch it, the graph that normally was like this is now going to get stretched out like that. Have you guys ever seen an old show that depicts like ancient, like like the Knights' time, where they had those torture racks? Have you ever seen that one where the guy's like this and then they stretch them? That's what your graph's going to do. When you stretch it, your graph might be like this, but then eventually it'll get skinnier. The bigger the number, the bigger the stretch. Okay? When it comes to shrinking, I've also seen it called a compression. What does it mean to shrink or compress? It means to push together. Okay? What's going to happen if you flatten something? Take a ball of clay and flatten it out. What's going to happen? It gets wider, right? If you had a little ball of clay and you flatten it out, it gets wider. That's what happens to the shrink. Okay? So, if we're going to stretch it or shrink it vertically, which way is vertical? Up and down, right? First of all, we are going to be outside the grouping symbol. Now I want you to identify something that happened. Remember when we added and subtracted? When we were outside the grouping symbol, we shifted up or down. That was vertical there too. So anytime you're outside the grouping symbol, you're always, always, always vertical. Okay? So when it's a stretch, so this would be a vertical stretch, if the number is greater than 1. Whatever that A is going to be. And I'm going to tell you or show you where it's going to be located at. But if the number is greater than 1, it's going to be a stretch. Higher the number, bigger the stretch. Okay? It's going to be a shrink if your number is from 0 to 1. Does anybody know what that's called? What kind of numbers are from 0 to 1? Does anybody have an example of something that's from 0 to 1? Not in decimal form? What kinds of numbers are from 0 to 1? Fractions. Right. Do not be confused with the fractions because sometimes they'll try to trick you or throw you off. They will always be in fraction form. Like it'll say 1/3, 1/2, 1/4, 3/4. Be very careful because they'll try to throw it in there on you like 5/2. 5/2, yes, is a fraction, but it's bigger than 1. So now it goes into a stretch. The smaller the fraction, the wider it gets. Does that make sense? The smaller the fraction, so 1/3 is smaller than 1/2. Do you guys know that? Okay? So when you see things like that, the smaller the fraction, the wider it gets. Okay? So I'll give you an example of this one before we do horizontal. So let's give you a function that has, let's see, Vitaly, give me a number. 5. Hope, give me a parent.
Quadratic.
Quadratic? Okay. X squared. So, oh, here's what I almost forgot. Oh, good God. Shame on me. Let me scroll back to that screen real fast. It's a stretch or a shrink, vertical, outside, stretch, shrink. I never told you what operation we were doing. Anybody have any idea? If adding and subtracting was shifting and negatives was reflection, what other operations do we have? Multiply, right? It's your multiplying. That's what the stretch and shrink does, is it multiplies. I don't like to use the letter X for the multiplication anymore, just so that you guys are aware of it, because X is a variable. But 5 times X squared. Is the 5 inside grouping symbol or not? Not. So this is a vertical. Now remember when I told you about the up and down, left and right? I never told you guys you had to do vertical, because up and down is pretty much self-explanatory. You're going to have to write vertical. You cannot just tell me it's a stretch or a shrink. You know why? Because horizontal also has stretch or shrink. So if it is multiplying and it's outside, just write the word vertical or abbreviate it. Vert is okay. Is this number higher than 1 or in between 0 and 1? Higher. So this is going to be a stretch by 5. How did I get the 5? Because that's the number Vitaly gave me. She gave me the number 5. Okay? So I'm going to draw the parent on there first. Parent is this parabola. Why was the parent the parabola? Because that's what Hope picked. Okay? If I stretch it out by 5, what's going to happen? So here I am. Stretch means what? Get skinnier or get wider? Skinnier. When you're stretching, the Laffy Taffy, right? It gets skinnier. So where should my graph go? Should it go on the outside of the existing one or inside of it? Inside of it, right? By a factor of 5. It should come in here somewhere. If you're unsure of the graphing, to be realistic with you, you could plot points. And that means you put in numbers for x, find out what y is. On the original parent, if I would have put 1 in there, 1 squared is 1. But with the multiplied by 5, when I put 1 in there, 1 squared is 1 times 5 now goes, instead of going up 1, it goes up 5. So that's where the stretch comes in. If that number is higher, guess what? It gets up faster.
If it's inside the grouping symbol?
If it's inside the grouping symbol, then we have a different one. I haven't talked about that one yet. Okay? So on a vertical stretch by 5, it should go inside the parent. Now, real quick, how are you going to know which one the parent is and which one the new one is? Or the child, as sometimes I've heard it referred to. How are we going to determine the difference between the two? Could you label it? Yeah? Could you use different color? Physically, like a colored pencil that would do it, like one in pencil and one in like blue or something like that. Yes, you could. And if you want, I have some over there in the cup. Okay, just so that you are aware of it. I'm going to give you a second one on here. Same parent, but this time we're going to go that route. We're never going to get done. Am I multiplying inside or outside? Outside. So automatically, I'm vertical. am I a stretch or a shrink? Shrink. Why?
Less than 0.
It's less than 0. No, it's not. Less than 1. Greater than 0. So if I shrink something, what should happen to my graph? Should it get skinnier or wider? Wider. By a factor or by a fourth. Which means if I had 1 of something, whole of it, I cut it down a fourth of the size. So it should come in here somewhere. Again, once you get your graphing calculators, could you actually type that in and get the picture? Sure you could. Me personally, I'm more interested in whether or not you know what's actually happening to it. I think all of you should be able to put something in your graphing calculator and you'll be just fine graphing it. That's not the issue. The issue is whether or not you know what's going on. And that's where telling me what's happening is more probably important than the actual graph is. Because with the graphing calculator, we're going to be able to do it. We still have one more to go, but we're not going to finish. Because we're right at, the bell's going to ring, right? Does it ring at 10?
Yeah, no, 55.
55 or 10?
We're at 50.
Yeah, we're at 50. So here's what's going to happen. Tomorrow, I'll finish it off, whatever we need to finish off. There's like 1 or 2 more things. And then we'll have the whole time to work. For the most part. Okay?